Hi there, welcome back. We continue our discussion of the geology of Norway. This would be part two, uh, the petroleum resources of this beautiful country. I'm Robert Font, a certified professional geologist and a proud member of the AIPG. In terms of proven oil reserves, at the end of 2019, the world had 1.73 trillion barrels of oil. Listed on the left are the top 10 countries: Venezuela, Saudi Arabia, Canada, Iran, Iraq, Russia, Kuwait, the UAE, the USA, and Libya. Norway sits at number 22 with approximately 5.14 billion barrels of proven oil reserves. In terms of proven natural gas reserves, at the end of 2020, the world could claim 7,257 trillion cubic feet of natural gas. The table provided shows you the top 10 countries: Russia, Iran, Qatar, the USA, Saudi Arabia, Turkmenistan, the UAE, Venezuela, Nigeria, and China. Norway sits at number 17 in the world with about 72 trillion cubic feet of natural gas. For Norway, since production started in 1971, oil and gas has been extracted from 115 fields in the North Sea and in the Norwegian continental shelf. Some of the most notable petroleum fields are listed here. Ekofisk was the first big discovery, and that is a story in itself for another time. At the end of 2020, 90 petroleum fields were producing oil and gas in Norway, and 3 new fields have started producing since then. Of these 90 fields, 67 lie in the North Sea province, 21 in the Norwegian Sea or the Norwegian continental shelf, and 2 in the Barents Sea area. In 2020, Norway produced approximately 1.4 billion barrels of oil equivalent. That's oil and gas combined, with a corresponding export value of about $38 billion US. And petroleum constituted about 40% of the country's total exports. The events that led to the generation and to the accumulation of hydrocarbon resources in Norway are summarized here. In the Triassic, we had intracratonic rifting. In the early Jurassic, we had marine transgressions and the deposition of the key source rocks that are so tremendously good for Norway. In the mid-Jurassic, we had mantle upwelling, the formation of the North Sea dome, and then a lowering of sea levels and the deposition of the key reservoirs where we find the oil and gas. In the late Jurassic to Cretaceous, we had the extensional rifting of the North Sea Graben province with fault rotation and trap formation. In the Cretaceous period, we had the opening of the Atlantic Ocean and the creation of the Iceland hotspot. And post-Cretaceous, we had the alpine orogeny, the subsidence of the North Sea basin, and the post-alpine rifting. Norway enjoys some of the best petroleum source rocks that you find in the world. In the North Sea Graben province and the Norwegian continental shelf, the source rocks are mainly Jurassic, the Malm-Kimmeridgian organic rich anoxic shales. These are known as the hot shales. Among the well-known hot shales are the Kimmeridge clay, as well as the Mandel, Dropney, and Tau formations. They have excellent richness and maturation. The main kerogen type that Norway enjoys is type 2, which is derived from marine algae and plankton. That type of kerogen produces oil when mature and gas when over mature. There are some areas where you find some type 3 kerogen that is derived from woody land plants, if you will, and that produces gas from the beginning. Total organic carbon, or TOC percentage, is what we use to classify how good a source rock might be. Anything more than 1 is good, more than 2 would be very good. Well, guess what? Norway's source rocks have typical TOC values ranging from 2 to 15 with an average of about 5. Not too bad, huh? But source rock richness is not enough. We have to have source rock maturation. Uh, the RO value, or the vitrinite reflectance value, is an indicator that we use to classify the maturation stage. From 0.6 to 1.2, the maturation is good and it produces oil. Well, guess what? In Norway, the source rocks have RO values that typically range from 0.6 to 0.9, so they are within the oil range. And the maturation time span is from all the way from Cretaceous time to present day. As you know, the source rock is the rock where the hydrocarbon is generated. But the hydrocarbons generally migrate out of the source rock into a rock that has greater porosity and permeability. That defines what we call the reservoir rock. Well, the petroleum reservoirs that we find in the North Sea Graben province and on the Norwegian continental shelf are summarized in the table that I'm presenting here. Let it suffice to say that the best reservoirs are the submarine channel sandstones of Jurassic age. You can also find some good reservoirs in the Cretaceous chalk, as the greatest example is Ekofisk, as well as some of the Paleogene submarine channel sandstones and submarine fan sandstones. Once petroleum has been generated and it has moved from the source rock into the reservoir rock, then you need some sort of structure to trap the hydrocarbon and a seal to prevent any further migration. In Norway, the typical petroleum traps and seals in the North Sea Graben province and in the Norwegian continental shelf fall under the major categories of structural traps and stratigraphic traps. Structural traps are found mainly within fault blocks and associated with horst blocks. Stratigraphic traps are related to submarine fan complexes and permeability barriers. The seals that we find in the area are provided by the fine-grained tertiary sediments. So far, we have referred only to the petroleum source rocks, the reservoirs, the traps and seals that we find in the North Sea Graben province and along the Norwegian Sea or the Norwegian continental shelf. But what about the source rocks, the reservoirs, the traps and the seals that we find in the Barents Sea area? Well, the source rocks in the Barents Sea area are generally older than the ones that we find in the other provinces. In the Barents Sea area, the source rocks are generally Triassic to Permian and Carboniferous in age. The reservoirs are Jurassic to Middle and Upper Triassic. As far as the traps are concerned, we find very large structural closures in the area, but these are generally not filled to the spill point. So far, we have spoken only about conventional hydrocarbon resources, but Norway also has a lot of potential in terms of unconventional hydrocarbon resources. Keep in mind that the country has more than 9,000 vertical feet of Jurassic anoxic shales, tremendous source rocks. So the unconventional possibilities include shale gas, shale oil, coal bed methane or CBM, and methane hydrates that you find in the deep ocean along the coast. Uh, it is worth mentioning that 1 cubic foot of methane hydrates is equivalent to 164 cubic feet of methane gas. So the punchline is this. In terms of hydrocarbon resources, Norway is a very wealthy nation. Now, if and how Norway is going to utilize these resources in the future is yet to be determined based on the country's climate change initiatives. But it's worth to point out that the current day value of Norway's petroleum fund is in excess of $1 trillion US. Well, that finishes part 2. I hope you have enjoyed it. See you later. Bye.